have we covered in the first two chapters. In the first chapter, we looked at how the main topics, how we can collect information based on which we can draw conclusions about a population. So it was about data collection. So when you see a poll saying, today there are elections in Canada. So last week, polls came up saying the result, Trudeau will win or not win again, the recall or whatever they're doing. It's more complicated than that. So you should always say, wait a minute, tell me how you selected your sample. I don't believe anything you're saying. Tell me how you selected your sample, how you collected the information, what was written on the questionnaire, what are people interested in? Maybe they voted for him for healthcare. Maybe they voted for him or not voted for him for some other policy. You have to give me all this information. I cannot take your answer as a valid answer before you tell me all these things. So now, assuming that the sample was correctly selected, and we have several techniques. We discussed one in detail, the simple random sampling method, when all samples of size n have the same chances of being selected. We also looked, we did not look in detail, but I mentioned other schemes, like, for example, systematic sample or samples that I'm missing a word, stratified sampling. So we know other techniques. We didn't look at them in detail, but we know they exist. So simple random sampling is not enough. It's not the only one. Okay, what did we do? So the data is collected correctly. The sample is representative of the entire population. No particular group was omitted. So it's a representative of the diversity or representative of the certain study, that certain population that we have the eye on. Then what did we do next? We looked at some organizing with tables and graphs and charts. Why? Why didn't we want to do that? Just to see what the data is telling us. Some people use is for data, some people use are for data. Both work. So both are okay. So we're looking at graphs that may tell us some information about the data. Finally, this is step 3 today. We're going to look at a numerical representation of the data. So we have the data correctly selected or gathered. We looked at tables and graphs, but now we want to look at a numerical summary of the data. So this is chapter 3. I know I talked too much. Sorry about that. Okay, so chapter 3 deals with numerical summary. Numerical summarizing of data. So we're going to look in this chapter, we are only responsible for 3.1 through and 3.2, as well as 3.4 and 3.5. That's all you're going to see in my lab math and in Canvas, of course. So 3.1 deals with measures of central tendency. So what are they? First of all, let's list them, and then we'll talk about each and every one of them. Mean, median, and mode. Let's talk about the mean first. And also, we want to refresh our memory on the notation for a population. They're different. And notation for a sample. For the population, does anyone remember how do we call all these? We don't have them. So how do we call them in general? What are these for the population? Anyone? Give it a try. We use the word for anything that we don't know about the population. If we don't know the population mean, we use a particular word for it. If we don't know the median or the mode, we use a particular word for it. Anyone remembers that word? Okay, parameter. So the population mean is a parameter. It is not known. What word did we use for the sample mean?
Statistic.
Very good. Who was that? Emma?
Emma.
Thank you. Yes, indeed. So please remember. Now, notation-wise, let's take a look at notation. Notation, this is the Greek letter mu. I don't know how to write it in English. So it's mu. It's U, but with a long tail at the beginning. For the mean of the sample, the notation is X with a bar on top. And that's how we read it, X bar. How are they determined? They're determined in the same way. The formula is the same. Before I show the formula, I would like to talk for a moment about a symbol. So when we want to write, let's say, x1 plus x2 plus x3 plus x4, this is not a big list. And I will not use this symbol that I'm going to show you now. But it can go from x1 through x500. And maybe I should just write that. Plus 3 dots plus x500. So in order to condense this addition and not have to write it like that long, we are going to use the Greek letter S. And this is what is called the sigma notation. Sigma notation. Also called the summation notation. I would like you to know what this means. And the summation notation always has a index. We like the indices to be I, J, or K. So from I equals 1 till the very last one, which is 500, from xi. They're all x and I. So the summation means sum, adding all the time, adding. So when I is 1, I have x1. Then the summation says plus. When I is 2, when I is 3, dot, 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 till I get to the last one, which is 500. So this really means I'm adding all of them from the very first one till the last one, which is 500. We're going to use this notation. We don't have to use it in calculations, but in order to explain, we need to know what this represents. It just says add them all. Add them all from the first to the last one, which is 500. Now, why don't we use this notation? Why bother with a Greek S instead of our letter? Well, because it's inconvenient. I can't use the index. I cannot put the index. So S will not work. The sigma, which is the Greek letter S, is much better for this notation.
Also, wouldn't it like interfere with other variables? Like if we had like S as a variable?
Yeah, but if I write it as big as this one is, but you have a point. I agree. Okay, so then how do I determine these? Before we continue, does anyone remember what is the notation for the entire population size? And what is the notation for, say it again?
It was capital N.
Thank you very much. That's the sample size. That's the population size. Excellent. And for the sample,
Lowercase n.
Lowercase n. So now these two are calculated in the same way. The sum of all xi divided by the entire number. It's the average. If I have 10 numbers, I add them up and divide by 10, and that will be the average or the mean. Same thing here. It's just the notations are different. But the same thing, the sum of xi that I have in the sample, all these, I'm adding them up, and I divide by the sample size. Okay, so this is how we calculate the mean. We are going to look at examples in a minute. Now, what does the mean represent?
Average.
Yes, the average, the center of gravity of the data, yes. Okay, so we always want to know where the average is, where the mean of the sample is. Okay, now let's discuss the median. What does the median represent? The mean,
like the middle of the
exactly, and I'm just going to give you an example. Just give me 5 numbers as sample size. So our next discussion is about the median. Just give me 5 numbers, any numbers you want.
10, 11, 15,
5, 15, and 3.
24.
Okay. And 24. I want you to start with an odd number first, and 1. And then you'll give me an even. So 2, 4, 6, 7. So the sample size is 7. In order to determine the median for an odd sample size, 7. First, I have to arrange them in ascending order. Of course, 1 will be the first, 3 will be the next, 5 will be the next, 10 will be the next, 11, and 24. And I missed the 15 and 24. Okay. And here's what we do. How do I determine the median? The median is right in the middle. As you see, I have 3 observations on the left of the median and 3 observations of the right. So this is exactly in the middle. So the median here is 10. What does the median say to us? It says that 50% of the observations are smaller, and 50% are higher. 50%, 50%. Now, give me another example in which n is even. Or we can use the same sample and let's drop the last one. So I have 6. So I have 10, 11, 5, 15, 3, and 24. How do I determine the center, the median?
Wouldn't you find the mean? Well, first put it in ascending order, but then find the mean of the 2 closest to the center.
Excellent.
Okay.
That's it. Thank you very much. Who was that? Gavin?
Yeah.
Okay, thank you. So 3, 5, 10, 11, 15, 24. You see, these 2 are 2 observations, smallest and the largest. At this point, I cannot choose. The median here is a value in the sample or an entry in the sample. Here it will not, because I will have to add these 2, exactly as Gavin said, and divide by 2, find the average of these 2. So the median here will be 10 plus 11 divided by 2, which is 21 divided by 2, which is 0.5. As you notice, 10.5 is not an element in the data set. It still has the same representation. It means, so right here, it should be 10.5. I cannot put it as an entry. It's not an entry in the data set. But 10.5 is the point that divides the sample into 2 parts. Lower 50%, upper 50%. Okay, the next and the last one so far, and I'd like us to look at some examples. Mode. So a sample, first of all, what is the mode? The most frequent observation. a sample size, oh, I'm sorry, a sample does not have to have a mode. It does not have to. It may have a mode, it may not have, it may have one, it may have two. So here's an example with a sample with two modes. So this is the first and this is the second. Here is a sample with no modes at all. Or if you want to say everything is equal, so it's a uniform. The whole data set is made out of a mode, right? So there are different situations. Okay, so what I would like us to do next. So let me share my screen. Where is my screen? Okay, over there. Okay. I would like us to go to StatCrunch. So click on StatCrunch website. And let me know when you're there. Ready? So click on StatCrunch website.